What's happening, everyone? Welcome back to another video. On the last video we touched on the fact that we're going to be swapping out the 18T crank for the FSI crank, and that will allow us to increase the capacity of the engine, but it's not a straight swap. So I'm not going to get involved with, either Fords or the cast or all the rest of it. I really don't care. It makes little difference to the power goals that I have for this engine. But there is two main differences between these two cranks. The first one we touched on the last video, that is the stroke is different. So the actual offset of the big end from the main bearing centre line is different. So therefore this one can allow a longer stroke. Simple as that. The other main difference is for this ring gear as well. This ring gear is what actually drives the oil pump on the crank, and for the 18T crank this ring gear has to have 19 teeth, but for the FSI, TFSI crank they actually have 21 teeth. So what you have to do is you have to take this ring gear off here. It's just an interference fit, so it can be pulled off pretty easily. I got the machine shop to do this, to be honest, because I didn't want to break anything. This crank is basically ready to go into an 18T block and drive an 18T oil pump. So the only thing we have to do now is actually check that it's fit for service. So we'll be measuring the main bearings, the big end bearings, we'll be checking crankshaft end float, and it's all just to make sure that it's in good nick, because I don't want to be putting this into an engine and have problems with it. Yes, I want more power, but as I've said before in the past, I want reliability as well. So let's get on to measuring this up and we'll see what we've got. The really cool thing about using these cranks in a stroker conversion is that it's actually from the same family of engines, the same group of engines that the 18T is. So the VAG group EU113 engines, it's like a big group of engine design, and obviously some of them are slightly different, 1.8, 2 litres, blah blah blah, but they're from the same family of engines, which means that all of the measurements for the big ends, the mains, everything, it's all exactly the same. So now that we've got the 18T ring gear on, we can essentially just treat this as an 18T crank, and we can measure it versus what we should get for measurements for the 18T crank. So the first thing we'll do is we'll check the main bearing journals, and what we need to do there is we have to measure the diameter to make sure that they're in spec. It's really important that they're in spec, because if they're too small, if they're excessively worn, then that can cause all sorts of problems like low oil pressure or a bottom end knock. It's the main bearings which provide oil for the big ends. You can see here I've highlighted the oil galleries which take oil from the main bearings to the big ends. So you can bet your bottom dollar if you have a problem with the main bearing journal, you're going to have a problem with the accompanying big end journal as well. So the first check is to make sure that we measure across here, it's on size. We also do it in different orientations to make sure it's round, and then once we've got all the measurements for all of the main bearing journals, we'll then compare them. And if, for example, they're all in spec but say number 3 is excessively worn, out of tolerance, then we'd have to consider getting every single main bearing journal ground to an undersize, and that you basically got to do that. There's no point in having like one undersize and the rest perfectly fine. You would have to grind the whole crank to undersize. And the way we're going to measure it is pretty much the only accurate way to measure it for the accuracy that we require is using this, a micrometer. If you try and use like vernier calipers or something, it's nowhere near as accurate. So let's get on to measuring the crank. We'll record the details and we'll see what we'll get. So that's all the main bearing journals tested, and every single one of my journals is 53.97. My number 4 is actually 53.975 in one of the sort of orientations, but I'm really not bothered about that. That's absolutely fine for me. So 53.97. Now the spec for the main bearing journals is 54mm, but that has a tolerance which can take it down to 53.963. So as long as I'm between that sort of 54mm and not as low as 53.963, then I'm alright. And at 53.97, I'm absolutely bang on. I'm really happy with that. That's great. And the best I've ever seen for that is 53.98, and that's on a different crank that I've got. So 53.97 it's a tiny difference. It really is. It'll make no difference. Plus, because this is going to be a track engine, I'm not actually bothered about hitting absolute perfect tolerances. I'll actually allow them to be slightly loose in terms of like the journal tolerances, which will hopefully help promote oil flow and help with the fact that these things are going to need cooled because they're going to be running at high RPM. So I'm really happy with that. 53.97 across the board, and now we'll just need to measure the big ends. For this I have to use a different micrometer because it's in a different measurement range. So big ends, just like the mains, have to make sure that not only is each of the journals on size, but also that they're completely round. So I check the measurements in a few different orientations, and I'm happy to report that they are on size. They're all 47.77 millimeters in 3 different orientations on each journal. So I'm really happy that they're on size and they're round, and I don't have to get them ground under size. So that's really cool. The actual minimum tolerance on this is 47.758, something like that. So I'm actually well above that. I'm really happy with that. So these big ends are within spec. So the next thing to check is the crankshaft end float. So when the crankshaft bolted into the engine, it's bolted in with the 5 main bearing journals, and it still has forces perpendicular to their main bearings acting upon it, basically from the flywheel and the clutch at this side. They'll be bolted here, and every time you depress the clutch, the crankshaft has forces sort of in that direction, and it's the job of the number 3 main bearing cap, which is this one, to locate the thrust washers. That's thrust washers. Took us about 3 times to record this, you know. Kept on saying thrush. No, I'm not itchy. But it's the job of the thrust washers to keep the crankshaft located where it should. Now, there should be some end float, so there should be a tolerance where the crankshaft can move slightly, because if there wasn't any tolerance, then obviously the crankshaft would be locked up tight. So without a doubt there should be some end float, but obviously it has to be in a small window. And that window is 0.07 to 0.23 of a millimeter. And there's a wear limit of about 0.3, so it's actually quite a big window, to be honest. But all end float is the difference in measurement between the inner thrust face of the crank here on the number 3 main bearing journal and the external measurement of the thrust washers on the number 3 cap here. So what I'll do is I'll use this, which is a telescopic Miton gauge, and I'll measure the internal diameter of the thrust face. I'll then, using a micrometer, the same micrometer, measure the external diameter of the number 3 cap with the thrust washers attached, and then that'll be my end float. Simple as that. So let's get that measured now. Right, so the internal diameter of my crankshaft thrust surface is 25.02 mil, and the external diameter of my number 3 main bearing cap with thrust washers applied is 24.88, which gives me a crankshaft end float calculated of 0.14 millimeters, which is bang on, nigh on in the middle of the actual tolerance of 0.07 to 0.23. I'm really happy with that. So again, another indication that the crank is the right size. The thrust washers will be perfect, really good. Now obviously, because I'm only using half of the thrust washer, it's only really half of the test, so I will have to do this again when the crankshaft's in the engine itself. When it's in the block, we'll do another crankshaft end float check just to make sure it's within spec when we assemble. So that's crankshaft end float. Right, the final little measurement that I need to take on the crank is the rod axial clearance, and it's similar to Endfloat. That essentially it's the float of the rod on the actual big end journal. So you measure the internal diameter of the big end journal face there, and then you also measure the external diameter of the rod, and then the difference between that is your actual rod axial clearance, and it should be between 0.1 and 0.3. I think the wear limit's something like 0.4. It's huge really, and mine are all 0.1415, so right bang in the middle, perfect in my eyes anyway. So that's all the measuring done on the crank. Every single bit of measurement that I've done on this crank is absolutely bob on. I'm really happy with all the clearances. Everything is perfect, or perfect for what I need it to be anyway. The last little thing to do is just check the overall condition. I have had this crack tested by the machine shop, but you know, after that you just need to make sure that the threads are okay for like your crank pulley bolt, to make sure that the flywheel bolts are all good as well, because they can pick up thread lock and they can be a bit minging. And then just give the whole thing a damn good clean. If you suspect that any of the oil galleries are blocked, then you need to get something up and clean them out. I've just used brake cleaner and compressed air, and that's what I'll do before I install it in the engine as well. So that's the crankshaft out the way with. Really happy with that. So the stroker part of this engine is looking good. Now we'll just need to check absolutely everything else. So next video, rods. As always, if you like this video, found it entertaining and informative, then please give us a like, give us a comment if you're interested in discussing this further, or if maybe you think different to what I think, then please let us know. And as always, subscribe to see the rest of this come together. Thanks very much for watching. See you on the next one.